Welcome to Future Talk. On today's program, we're going to talk about how to use modern technology to create livable and sustainable homes and offices that are highly functional, ecologically sound, and aesthetically pleasing. My guest is Terry Beaubois, an architect, researcher, and educator who's been involved in creating new architectural methods for many years. Terry was the founding director of the Creative Research Lab at Montana State University and directed the ecoSMART house project in Bozeman, Montana, which received the House of the Year award from the U.S. Green Building Council. He sees a connection between the habitats of manned spaceflight and the kinds of homes needed on Earth, and served as chairman of the Advanced Technology Application Committee, a joint committee of NASA and the American Institute of Architects. He's currently in discussions with the Stanford University Architecture Program about a collaboration to set up a community design and research center to advance his and the architectural program's ideas. Terry, welcome to the program. Good to have you today.
Thank you very much, Marty. It's a pleasure to be here.
Terry, what do you think is the broad direction of architecture in the next few decades? What are we heading toward?
Well, it's a really exciting time. I mean, I haven't felt this kind of energy in an area, both regionally and professionally, since the early days of Silicon Valley. I was here in the late 70s, early 80s, when there was a vibrancy and an explosion of innovation that we're going to see in the next couple of years here. It's already begun, but I think it's going to continue, and I think it's going to affect architecture and the design of buildings directly.
Now, you were involved in something called the ecoSMART house in Montana. What was that project all about? What was that attempting to show?
Well, it was a very, very comprehensive project. It was based on the idea that collaboration horizontally through the different disciplines, architecture, engineering, construction, and including government and the product manufacturers, the companies that are involved in the building, working together can create a project that is better, not easier. I often have people say, well, is collaborating easier? And I have to be honest and say that no, the reason to collaborate is because the project becomes better through that collaboration. And we did that with this project. The other thing is we had three specific goals for the house. One was that it should be sustainable. The second was that it should be low energy in its use. And the third was it should be designed for a disabled person because the daughter in the family was in a wheelchair. And so we took those three concepts and put them as major goals of the project. Many projects have one of those three, and we felt that by making it a collaboration and by creating those three goals, that it would be a real test of the team and our project.
Now, are you able to accommodate a disabled person without compromising on the features for people who are not disabled?
Yes. In fact, we did a couple of things. First of all, we hired the young lady who was in the wheelchair to work in our research lab to do some of the research in regard to disability design. And the interesting thing was she found things that I don't think a person who wasn't in a wheelchair would have found. We watched her do Google searches and we watched her search the internet, and she had a different approach. We all do when you really look at it. We think Google is one thing and you just put a word in and everybody gets the same return. But someone who's disabled, they have certain criteria and priorities that came out in her searches, and her contribution was significant to the project.
We actually have some slides showing the house. Can we see that first slide, please? Okay, so this is obviously the exterior.
Yes, this is a house in Montana. It's in a subdivision. It's actually a laboratory disguised as a house because it is a significant combination of mechanical systems and products that wouldn't normally be in one house.
And what are some examples of that? What's different about this compared to an ordinary house?
There were a number of things. One of the things you mentioned earlier, my involvement with NASA, it was really rewarding to watch a project and be able to incorporate a technology and windows that had been developed based on NASA technology from the 1970s that had been transferred to a company in Palo Alto, Southwall Technologies, and then eventually see it become used in this house. And it's significant in that it did, the space program forces a mission-critical approach to things, because you have to keep people alive. I think sometimes pushing the boundary, pushing the edge like that makes us all become very much aware of where the design can go.
You also have to save energy up there and not let it leak away.
Absolutely. One of the most interesting things I ever saw was a conversation in a space station design team, and you talk about a power struggle. That was the true sense of those words that I saw, where people were really struggling to get enough power for their experiments versus someone else getting that power, because there was a limited source of energy. So when you look at energy as a limited thing, as opposed to, well, we have enough energy, we just leave the lights on in the house, it's a completely different approach than when you're really trying to save as much energy by not using it as possible.
Let's go on to the next slide. All right, so that looks like the kitchen of the house.
Mm-hmm.
Okay, so what's different about this? How does this compare to an ordinary kitchen?
Well, you can see a couple of things just by first glance. One, the countertops are a really interesting material. It's actually a paper product that is impregnated with certain other materials, and it's made into a hard surface. So the countertop materials were very sustainable, recycled materials. You can see the windows in this picture, and you can see how they're not obscured by draperies or blinds because of the nature of the glass and the film that's in the glass.
What's different about the glass compared to ordinary glass?
Many windows have this feature, but we were able to custom design the film that's in the glass. It's in the between the layers of the...
You mean there are two panes in a space between the panes?
Yeah, there's actually three in this one. And it is actually able to eliminate the UV, which is the heat gain in the house. So one of the things that, whether it's in California or Montana or any other state, there's always places with beautiful views, and so people design their house for the views. And then often there is a impact from the sun, either in the morning or in the afternoon, the evening, sunset, so that it requires that people put the blinds down. So what we wanted to do was to create a window system where you could have the view all of the time and not worry about the solar impact.
I mean, it filters out ultraviolet light?
It filters out the heat, not the light so much. So you could, we had an open house, and some people were sitting in the window seats, and a contractor came in and said, in my houses, if people were sitting in the window with direct sunlight on them, they'd be baking right now. And there was no heat gain, because that's the way the window was designed, not to have sort of random impact of heat gain at various times, but to keep the house sort of very, very tight. That's one of the new things about designing houses now. If you make them...
You also don't want heat to leak out of the house in winter.
Exactly right. In fact, they have this thing that we call the Ghostbusters gun, where they can go around the house and you can see where anything is leaking in or leaking out. And then you can seal these cracks, or you can mark them, and then the subcontractor can come in and seal the cracks. And that's something that we didn't have before. It's almost like you have the ability to see things that people couldn't see before.
I understand that there's a lot of work being done these days in materials research, putting together materials that have different or maybe better properties. Do you use any special materials in this kind of house?
Absolutely. We first started looking at sustainability as a function of materials. We were looking at roofing materials, exterior materials, flooring materials, and things.
When you say sustainability, that means that you're not impacting the environment, you're not using up a precious resource that we're going to run out of?
That, and that we're not having to replace or paint the house every year, or replace, some of the materials because they wear out or they have a short
so it's a low maintenance?
Yeah, the whole idea of easily maintained house. The other thing that we added during the design process, there were a lot of students in the lab from architecture, film, music, art, engineering, business school, library. We had as many students involved as possible, as well as faculty. And there were some late night sessions, and one night we were sitting around talking, and we realized that there's a short story from 1959 about a house that's built, and the drapes go up in the morning and the coffee pot starts percolating, and you're about 3/4 of the way through the story and you realize, wait a minute, there's no people in this story. And we realized that the sustainability wasn't about the materials. all of the things that we do, whether it's sustainability, whether it's low energy use, is all about human comfort. That's the key, is to keep the human factor in the design of the house.
So you're saying technology is not that useful unless people are actually deriving some benefit from it?
Well, technology is very useful to attain that kind of benefit so that the humans are living in an environment that's comfortable and is sustainable. It's sustaining the human being as opposed to just the material that's in the house.
I think we have another slide. Can we see the next slide? Okay, so this looks like it's maybe in the basement, if the house has a basement.
It is.
And this looks like maybe the plumbing and the electrical conduits.
Yeah, this was interesting because at the very beginning of this project, one of the mechanical engineers said, we can make this thing look like the mechanical room in the Yellow Submarine. And everyone laughed. And then it was interesting to see the subcontractors. This is almost like jewelry in there. You go in there and it's beautiful. We take people in the mechanical room and they want things exposed, all the connections, all the brass fittings, all of the welding. This is just a work of art. But at the same time, it is a work of complexity, and it also is showing how the systems start to work together so that we don't lose heat. We're capturing all the heat. We're not just exhausting it. And we're not even wasting the hot water that is going through the pipes as far as that heat.
Now this is on the grid, right? I mean, it's not generating its own energy. It's plugged into the electrical grid. It gets its water from the same place that everybody else gets it.
It is currently, but it's designed so that it could be in the future. We have the potential for adding both photovoltaic and hot water solar systems to it.
Okay. And I understand that this house won an award for Best House given by the U.S. Green Council.
Yeah, we were very pleased.
Green Energy Council. And we have a picture of the award. There's the award right there. There's your name sort of in the lower left.
Mm-hmm. And it's a real team effort. You can see there's a lot of people involved in this. The contractor, the structural engineer, the homeowner, the university, and the major corporate sponsor. So that was the key. This is a lot of people working together successfully to create a project that is award-winning.
Now, is this an experimental demonstration house, or is there somebody actually living there now?
Right now, it is being run as a laboratory. It's like a living laboratory. Later this year, the family will move into it, and it's actually a 3-generation family. So that's part of the design of the house, is for multi-generational living, and also to test, to make sure that we've designed a house that normal people can operate, not just the mechanical engineers who designed it and installed the equipment. So that'll be part of what we'll be doing, is adjusting when the family moves in to learning how successful they are in being able to control the environment.
How would the cost of a house like this compare with a regular house? Since this is a one-of-a-kind house now, it's obviously a lot more expensive, but if it goes into large production, would it economically be better than a traditional house? Would you save money by buying this kind of house?
Well, the goal of this house is not to be a prototype that would be replicated over and over again. The goal of this house, we have 11 different mechanical systems in this house that we're going to test head to head. And we will see for our region, which was the sort of the Front Range, Northern Rockies region, because every region on Earth has its own sort of microclimate, whether it's a lot of cold, a lot of heat, a lot of humidity. Montana is very dry, so the solution for Montana will be adjusted when it goes to other places. And as we learn more about, no one has done what we did, which is put so many mechanical systems in them that in the same time, in the same place, you can test them head to head, A against B, A against C, A against D, and see what kind of results that we get. One of the magazines called Our House will be the most monitored house in North America. And we hope that the value to everyone who's building a house is the information that we're gathering and what we learn from testing this house as a laboratory.
When you say it's monitored, that sounds like a developing trend, what people are calling the Internet of Everything, where you can put some kind of sensor on just about any kind of object, and that sensor can detect things and report them instantly to the Internet, so you can see at a glance temperature, any motion of anything, movement of fluids through pipes.
Absolutely, and we do that in this house, and what you've just identified is really one of the most exciting aspects of the future of architecture right now, because as we become able to design our buildings and design our environments to coordinate with this sensor information. For example, in the old days, you'd drive into your driveway and take your garage door opener and push a button and your garage door would open. In the future, we'll be able to design a house that the garage knows you've just driven in the driveway and your car knows, and if you want to put it in the garage and you opt into these kinds of opportunities, that the building knows who you are. It's not just this static big object sitting there. And applied to commercial buildings, imagine you and I have an appointment at 3 o'clock in a corporate headquarters. When we walk in the building could know who we were if we opt into that kind of sensor communication. It could say that the meeting's been moved to another room if it has been. In other words, the building can help us accomplish the things that we're trying to do. Whether it's a house or whether it is a commercial building, we're going to be able to build as architects buildings and environments that really support human activities and human interaction.
Is there a possibility of loss of privacy with something like that if sensors are following you around wherever you go all the time and reporting everything you're doing?
That is a big concern, and it's real and it's serious, so I don't want to say no, there's no concern. But as part of the opt-in, we all have to learn what we want to participate in and what we don't. I think where we're going to see significant buy-in from most people is in the medical and health fields, where if someone has a heart rate that needs to be monitored or an oxygen level that needs to be monitored, that may be okay that we're transmitting that information and being monitored. Whereas some of the other security that people are concerned about, they don't have to opt into those kinds of things. And I think the other thing is, I think we should take control of this technology and figure out what we want to use it for and not wait and find out what other people are using it for necessarily.
Now, you've also been involved in a lot of other activities pertaining to architecture. You've been involved in something called the AEC Hackathon.
Yes.
What's that all about?
Well, if you look at the age of digital watches, computers, the telephone, airplanes, they're outdistanced by the building industry by 5,000 or 10,000 years. It's been around a really long time, and it's had the ability to develop a lot of mom and pop organizations. It's not like the big five that used to be in the automotive companies or the few airlines manufacturers that we have. In the building industry, there's thousands and thousands of different small manufacturers. So it's a tougher industry to sort of improve. It takes a long time to improve it, and you have incredible cost overruns. So we think that by looking at and exploring with hackers, you know, young people that aren't used to not being able to do this or not be able to do that because it's not been done that way for so long, that we'll actually find some really interesting and exciting ways to improve the industry in a shorter period of time than if we just sort of wait for the large interests to sort of catch on to this technology and how it could be applied to the building industry.
So when you say AEC Hackathon, first of all, what does AEC stand for?
Thank you for asking that. It's architecture, engineering, construction. And that is sort of the three categories that architects, engineers, and contractors are aware of. Of course, there's real estate, financing, and facilities management that bracket that as well. So it's a big industry from start to finish when you try to get information flowing from one end to the other.
So you're basically getting a group of computer hackers who may or may not work in the industry and sort of crowdsourcing it, combining their knowledge to figure out what's the weakness in the construction industry, what could be done better, what practice has been going on too long after it's no longer useful anymore?
That's an excellent analysis, because we had a hackathon in November, and we found it took people about an hour to discover where those problems were. People that had no familiarity with the AEC would say, wow, why do people do this? How come they don't do that? And these are things that have been known since 1972, and yet they haven't been addressed adequately by the industry itself. So an example of two areas that we're going to be addressing in this hackathon coming up is iBeacons is a technology that allows a thermostat or a smoke detector to be able to detect where you are, if you have a wristband on or a cell phone is, in a totally smoke-filled room. So a fire person could come in and find somebody that was there. I mean, there are reasons to use this that are very, very compelling. Again, respecting the security concerns that people have. Another one would just be able to control climate. The comfort of a human in a room is very, very important, and a lot of money is spent every year on thermostats and air conditioning systems and all of this. An example of what used to happen that people might not know and might have trouble believing is in a building not so long ago, the sun is on one side and that's getting hot. The other side gets no sun and it's getting cold. In some old building designs, they would blow cold air on the hot areas and hot air on the cold areas, and then someone said, what if we just move the hot air to the cold part of the building? Why don't we just use the air that's already there rather than just using mechanical...
You mean circulate it?
Yeah. And that's where, you know, because people wonder, well, how are you going to save energy doing this? The same thing that we've been doing. And that's an example of where somebody just looked at the system and said, this is hot, this is cold. Let's use the air that's already there and move it around.
One of the problems with heating a house is that sometimes if you're in one room and you want to heat that one room, you have to heat the entire house, which can be a pretty expensive proposition. Do you see architecture developing so that each room can maintain its own temperature?
Yes, and what you're talking about is zoning. And what can happen is there are these pumps and fans that are incredibly efficient, incredibly inexpensive relative to previous costs, and very, very low energy use, so that we can design something that might not have been affordable except for a large corporate facility in the homes in the future. Because they found that when I went to school, the psychometric chart, or how you figure out whether someone's comfortable or not, was just x-axis and y-axis, and it was temperature and humidity. The reality is there's 27 factors that go into whether someone is comfortable or not in that room. Has to do whether they're tall or short, how much they weigh, whether they're a man or a woman, whether they have a sweater on or not, and whether they just came in from outside. Because we've all experienced where someone comes into the room and they're uncomfortable all of a sudden as they start fiddling with the thermostat. So being able to look at who's in the room and find out what's the right environment for them is going to be a feature in the future, as opposed to it's 72 degrees no matter who's in the room.
Now there's another thing that you've been involved in recently called Franchise for Humanity. What's that all about?
Yeah, this is an amazing thing, and in fact, Mei-Lin Feng, who you know, and does a lot of work in Palo Alto, organized with some other collaborators an event that was just really magnificent. We had a number of people from all over the world, all over the United States, and it's looking at I've talked to a lot of people, and the word franchise, sometimes people are thinking of like a business franchise, and the franchise actually means the right and the privilege to do something. And so what we're looking at is how people, whether it's in Silicon Valley or another area, can help every individual in the world have the same rights and privileges that we're benefiting from. And I'll give you an example of it, because it's sort of hard to come up with something. You're thinking of, well, are we going to, give fitness bands to everybody in India or something like that? There was a gentleman, Stephen Leventhal, who presented absolutely magnificent presentation. He does Fortune 500 training for executives, and he also teaches in a young woman's school in India. And he uses the same principles and sort of social technology in both instances. And so it sort of encouraged us all to think about, well, what can we do that we think is very high-tech and maybe oriented towards Silicon Valley or a industrial area that would be translatable in some way. And it was very inspirational to see him, how he has done that in his own life with his own capabilities, and it was very inspirational.
Now, is one of the goals of this to get more people involved?
Yes.
More people involved in getting into this field of new architecture, emphasis on the people who live there, better energy, more efficient energy, whole new designs. And how do I understand that you're doing something at Stanford now that might help bring more people into it.
Well, I've been talking to John Barton, who's the head of the architecture program there at Stanford, and it's an amazing institution. It's an amazing organization. They have Media X, they have the D School, they have all of these resources and capabilities, as does, if we look at the larger Bay Area, and include Berkeley and San Francisco and San Jose and Santa Cruz and the different schools. We're looking at how we begin to both do horizontal collaboration, which would be across disciplines, and also vertical collaboration, which begins to incorporate mentoring and people of different ages working together. And it's not a one-way street. I mean, there are sometimes the power users are 16 years old and the beginner is in his 40s or 50s, and so we can all benefit from that kind of collaboration, the vertical collaboration that happens. And sometimes the mentoring is up and sometimes it's down as far as the age is concerned.
We only have a minute or so left. How long do you think it'll be before the average family will be able to live in one of these homes that's sustainable and energy efficient, sort of custom designed so that it's suitable for just all the people in that family?
Well, I actually visited a house in Portola Valley recently that I think is as good as the Montana ecoSMART house. It doesn't have 11 mechanical systems. I mean, it has what it has, the way they've done it. But I think it's possible today to do this. I think they've shown this happening. And I think if people are interested in it and they're interested in talking to their architect and getting them involved in pushing the boundaries of what they may be used to even, I think there's nothing to wait for, really.
Okay, great. And we're going to have to wrap on that note because we are out of time. I've been speaking with Terry Beaubois, architect. We've been talking about some of the new trends in architecture driven by modern technology. Please visit our website, www.futuretalk.net. For Future Talk, I'm Marty Wasserman. We'll see you next time.